Hi guys, today we're gonna be talking about a very useful data structure called the heap. It is used in solving many data structure and algorithm problems, and also it's useful in real life applications. A heap is a data structure that organizes elements based on priority, ensuring the highest priority element is always at the top of the heap, and this allows for efficient access to the highest priority element at any time. So it's a data structure that really gives us access to the highest priority element at any time. So and that way we can easily access the highest priority element in our application. And we have two types of heaps, the minimum heap and the maximum heap. So the minimum heap will prioritize the smallest element by keeping it at the top of the heap. That's why we call it the minimum heap. So it's prioritized smallest element by keeping it at the top of the heap. So this is an example of the minimum heap. Now you see that at the top of the heap we have the minimum number, the minimum value, which is 2. So and that's it. So and we have the maximum heap. It prioritizes the largest element by keeping it at the top of the heap. So we can see for the maximum heap now, even for the same set of values, 12 will be at the top because it's going to prioritize the maximum value or element. The structure of a heap makes efficient prioritization possible, and this is basically due to the fact that heap is essentially a binary tree. A binary tree is actually a structure that looks like a tree. So it's a structure containing nodes and edges. So this is what we call the node. This particular node, this is the node value for this particular node 2. So and these are edges. Edges joins two or more nodes together. So a heap is essentially a binary tree, and if we are considering a minimum heap, for example, we can see what it look like in binary format or in binary tree format. We see that the root node is always have a value that is smaller than any of the children nodes. So at any point in the tree, the node will always be the value of the node will always be smaller than that of its children. Look at this node 4 now. You see this is 4 and this is 7 and this is 5. This is that 4 is less than both its right child and its left child. So and that is essentially how a minimum heap is structured. So this way, this structure will allow us that the root node will always be lesser than any of its children, that is any of the other node in the tree. Here is a time complexity breakdown for common heap operation. We have the heap operation that is used to insert into the heap. So it takes log n time to insert a node or to insert an element into the heap, and what it means is that it adds an element to the heap, ensuring the binary tree remain correctly ordered. So and that's why it takes log n. It's not just inserting, it's not just adding or appending, it's actually adding an element while ensuring that the binary tree remain correctly ordered. Like now, if we want to put an 11 into this node now, we can either put the 11 at this point or at this point or at this point. Why? Because we can see that when we put the 11 at this point here, we still ensure that the root or their parent node is greater than each individual node, and even if we put the 11 at this point, is still greater than the root node. So it's just trying to place the element or the node in the binary tree such that it does not distort the arrangement or the order. So that's what insert does. So also for deletion, if you want to remove an element from a heap, it takes O log n time. So and that remove the element at the top of the heap and then restructure the heap to replace the top element. So what this means actually is that when we remove an element from the top of the heap, now say we remove 2 from this heap, now it's not just gonna remove and become rootless. It's the heap is gonna get restructured such that the next smallest value in the binary tree will take the place of that node that we remove. So it's gonna restructure itself to replace the top element. Another operation that we can do is the pick operation, where we just try to check, return the, here is return actually, so we return it without actually removing it. So that's what we do for the pick. It's just like we're trying to check what value or what node or what element is at the top of the heap. So heapify operation takes on time. So pick operation is going to take o1 time. That means a constant time, meaning that for any length of heap, for any value, it's just going to take a constant time to pick and to check the top element. Heapify now takes on time, and what it does is that it transforms an unsorted list of value into a heap. So let's say we have lists of values now that want to convert into a heap. So list is another data structure, is an array. So we want to convert it into a heap data structure. We can do that using the heapify method. So it's a method that a function that we can call, and it's gonna take on time. That is, it takes linear time to convert a list or another data structure into a heap. We also have a priority queue now. So a priority queue is a special type of heap that follows the structure of minimum heap or maximum heap, but allow customization in how elements are prioritized. So for a priority heap, we are gonna be considering different problems under this heap data structure, and I want you to follow along. So in my subsequent videos, so you are gonna learn about the priority heap in practicals. So it's just a type of it's just another type of heap, just like the minimum heap or maximum heap. In fact, they have the same structure. It also uses a binary tree, but it allows customization. If you look at how we explain the minimum heap right here, we said that minimum heap is gonna prioritize the smallest elements by keeping it at the top of the heap, while maximum heap prioritize the largest element by keeping it at the top of the heap. But what if we are not dealing with values like this? What if we are dealing with other objects like strings, like booleans, like classes, or other things like that? So this minimum heap and maximum heap are actually talking about the smallest element and largest element, but priority queue will give us more customization and expansibility on how elements are prioritized. So we can decide to prioritize string with a higher number of vowels. We can decide to prioritize prime numbers or any other things like that. So it just become more customizable for us. Now let's talk about the real applications from the heap data structure. So we use it to manage tasks in operating system. Operating systems often use a priority queue to manage the execution of tasks, and a heap is commonly used to implement this priority queue. So an heap is mostly used to implement priority queue efficiently. So when we run multiple calls and multiple tabs on our laptop and devices, the operating system is gonna assign priority levels to this particular task, and then a heap is mostly used to keep track of these tasks, so that based on the priority level is gonna execute the tasks, so and keep all of them in the queue. So for example, when multiple processes are running on a computer now, each process might be assigned a priority level. The operating system needs to schedule the process so that higher priority tasks are executed before lower priority tasks, and a heap is ideal for this because it allows the system to quickly access the highest priority tasks and efficiently rearrange. So that's one thing about heap that I discussed the other time. Even aside from giving access to the top and the highest priority tasks, whenever we are done with that, we are done executing that task, it knows how to shuffle it out and rearrange such that the new priority task that is supposed to be there is gonna be added to the top of the heap. So that's one application, and there are several other applications. So don't miss this interesting and crucial data structure. We'll be talking about some problems including combined sorted linked list, k most frequent strings, median of an integer string, and other high level questions that are asked in top tech companies. So do well to like, to comment, and to follow us and engage however in any ways you can because it's going to be of help to you. Who knows who is watching. And all right, thank you.